Okay, so now we're back here for part 3. Now we're actually going to skip around and get to warm up probability day 5, which is multiple marbles. Okay, so what happens if we're going to choose or pick more than one? Well, we'll start with problem 1 here, which is just a review. A bag contains 10 marbles, okay, 4 red, 3 blue, 2 green, 1 yellow. If you select one marble from the bag, so we will select 1, what's the probability that it is blue? Well, probability of blue, we have 3 blue out of 10 marbles, or 0.3. What's the probability that it's red or green? 4 red, 2 green. So the probability of red or green, we have 6 red and green total out of 10. That is 3/5 or 0.6. In this case, because it's divided by 10, it might be easier to write this 3/10 and 6/10 as decimals. What's the probability that it is not yellow? Now yellow, the probability of yellow is 1 out of 10. That means the probability of not yellow is everything else. So if I take my 100%, which is 1, and I subtract 1/10, what I get is 9 out of 10, or 0.9. And again, if that's kind of confusing to you, well, count the not yellows. 4 red, 3 blue, 2 green. If I add those up, I have 9, and I get 0.9. So what happens now? Let's say we choose 2 marbles from the bag without replacement. What is the probability that both are blue? Now, in everything that we've done so far, and what we did in number 1, we chose 1 marble. Yes, this was red or green, but it was only 1 marble that we chose. What happens if we pick 2? So imagine you have your bag of marbles here, and we've got, red, 4 of those, we've got blue, 3 of those, we've got some greens, and we've got a yellow. If we choose 2 marbles from the bag without replacement, so in other words, we don't put the marble back. When we pick the first one, we don't put it back before we pick the second. What is the probability that both are blue? So we're going to think of this in 2 ways. So we're going to do blue and then blue. For the first marble, we have 3 blues in the bag. So the probability that the first one is blue is 3 out of 10. But remember, let's say that we picked out a blue. When I get to my second marble, I don't have 3 blues anymore because one of them is gone. I took it out, but I did not replace it. So now there are 2 blues. And the other thing is, we don't have 10 marbles anymore. When we choose the first one, there's 1 less marble because we don't put it back. So this will become 9 in the second fraction. Now, what do we do with the 2 fractions? When we have multiple events occurring, the counting principle, which we learned before, says that when you have more than 1 event, and the first event can occur in this way, and the second can occur in this way, for both of them to happen, for this and this, to get blue and blue, what we do is we multiply. Okay? And with multiplying fractions, this becomes 6, 3 times 2, 10 times 9 is 90. But I want to simplify it. I can actually divide each of these by 6, and we get 1 out of 15. Okay, and 1 divided by 15, if I want the decimal, is 0.067, okay, or approximately 0.07. So 0.07, okay? So if we're going to choose more than 1 item now, the probability that they both happen is we're going to multiply the fractions. So the probability the first is red, so we're going to go red, and the second is yellow. All right, now for red, I'll use my visual here. We have 4 reds out of 10. This is a new problem, by the way. So we go back to 10 for part B. So we have all the marbles, we have 10, 4 of them are red, times. The second one is yellow. Well, we only have 1 yellow, so there's only one way to succeed, but we no longer have 10 marbles. We chose 1, and we didn't put it back. We did not, so this becomes 9, and what we get is 4 over 90. We can divide those by 2, and we get 2 out of 45. As a decimal, that's quite small, 0.04. So 0.04. How about the probability that both are green? So how many greens do we have? We have 2. And when I do this, you'll notice I break this up. I do one thing at a time. So let's imagine we're going to reach into our bag and we want to pull out a green. There's 2 ways to do that out of 10. Now we pulled out a green already. We already know that. So for the second green, we have to realize we just took one of these out. It's gone. So there's only 1 green left. And because we already removed 1 marble, we don't have 10 anymore, we have 9. Notice that the 10, 9 happens every time. Multiply the fractions, so we multiply numerators. 2 times 1 is 2. 10 times 9 is 90. That simplifies to 1 out of 45. And 1 divided by 45 is 0.02 repeating, so about 0.02. 0.02. All right, and then part D here, the first one is yellow and the second one is red. The first is yellow, second red. So probability of yellow, and then we go red. So the yellow marble, we have 1 out of 10. All right, now we just chose a marble, so now we only have 9 left in the bag. Now we want red. Well, there's 4 reds still there, so 4 out of 9. We get 4 divided by 90, and we get 2 over 45. It's kind of like part B, which is 0.04. What I want you to notice, though, is actually red, yellow, and yellow, red, they're the same probability, okay? Whether I choose red first and then yellow, or yellow first and then red, I will get the same answer to that. The order that I choose these won't affect what their probability is. Okay, so that's kind of an interesting connection to make. And so now we'll come down to number 3. This is the last problem here. If you choose 2 marbles from the bag with replacement, that means we take 1 out, but then we put it back before we take the second one. Okay, so we take it out, but then we put it back. What is the probability that, okay, and then we're actually going to do the same problems here, the same things. Let me draw our bag here. So we had 4 red, we had 3 blue, we had 2 green, and we had 1 yellow. Probability of blue, blue, both are blue. Well, we have 3 blues, so for the first one, there's 3 out of 10. The probability that we choose a blue. Now here's the thing. If we put it back into the bag before we pick the second one, when we make our second choice, hey, we took out the blue, but we put it back. So now we have 3 blues again, and we also still have 10 marbles because we did not keep the marble out of the bag. It doesn't go from 10 to 9, it will stay 10. And the blues will stay 3 because I put back the first blue before I picked out my second marble. Now when I multiply that, 3 times 3 is 9, 10 times 10 is 100. That's actually a nice easy decimal, it's just 0.09. Okay, so notice the difference. Notice that these did not change like they did in the first set because we are now replacing it before we make our next choice. What's the probability that the first marble's red and the second marble's yellow? All right, so probability of red, yellow. Well, red marbles, the probability is 4 out of 10. Yellows, we have 1 yellow. Remember, we already replaced our first marble, so there are again 10 to choose from. So these denominators will stay the same. 4 over 100, you could actually reduce that to 1 out of 25 or 0.04. Okay, 4 out of 100 is 0.04. Probability that both are green, so probability of green, green. We have 2 green out of 10, but then we put back the first one, so we pull out a green, great, but we put the green back. So now for the second marble, again, 2 out of 10, which is 4 over 100. That's the one we just did. Okay, same thing, 0.04. Probability that the first is yellow and the second is red. So yellow and then red. So we're going to reverse this one. Yellow was 1 out of 10 times, the red was 4 reds, but we put the yellow back. So we have 10 marbles again, and we get 4 over 100, which is again 0.04. These are the same again, which should make sense because going red-yellow or yellow-red shouldn't make a difference with our overall probability. And that is the end of part 3.